In this video, we'll discuss how to interpret the slope of a function. When we're measuring or counting a quantity, the slope of a function goes beyond rise over run to describe a rate of change. In the example below, we have a candle, a 10-inch candle that's burning. After 30 minutes, the length has decreased from 10 inches to 7 inches. Determine the rate of change in length of the candle as it burns. Describe how long the candle takes to completely burn to nothing. The graph shows two data points as the candle burns. So at time equals 0, when the x-axis is 0, we see the candle is 10 inches tall. The y value is the length of the candle. Then at 30 minutes, when we come over here to 30 on the x-axis, the y value is now 7. That is the data point that corresponds to 30 minutes later when the candle is 7 inches tall. What we want to do is see how the rate of change, the slope, tells us how fast the candle is burning. So the rate of change is the slope. We can calculate the slope as rise over run. We can also use our slope formula. To use the slope formula, we need two ordered pairs, and that's what we see here on the graph. We have 0, 10, and we have 30, 7. We can call this x1, y1, and we can call this one x2, y2. We put the numbers into the slope formula. And we get the slope, and then we can interpret it as a rate of change in inches per minutes. The numerator y value is length in inches. So this is a change in inches on top, and then in the denominator we're looking at a change in minutes. We can use those units to help us understand this negative 0.1. This is negative 0.1 inches per minute. It's a rate. And that's one of the very common uses of slope, is to measure a rate of change. We leave the negative sign because that tells us the quantity, which is height. It tells us that that height is decreasing. In this next exercise, we don't have a graph, but we are given the function. So a caterer charges $200 plus $10 per guest. So $200 down, and then there's a $10 charge on top of that for each guest. That works out to be y equals 10x plus 200, where x is the number of guests. We want to interpret the slope as a rate of change. We know that y equals mx plus b is the slope-intercept form, and that the slope in this function is 10. By comparing the two equations, we can see that the slope is 10. So that's the slope, so it's rise over run. 10 is not a fraction, but we can turn it into a fraction by putting it over 1. So what that tells us is that if we run 1, then we rise 10. So what is the run variable and what's the rise variable? Well, the rise is a change in y. It's y2 minus y1 over x2 minus x1. The y value is cost. So we're looking at a change in cost in the numerator. And in the denominator, it's x that's changing. X is the number of guests. So x is the change in the number of guests. So if we come back to here, if we have one additional guest, if the change in guests is 1, then the rise in price and cost will be $10. So the slope here can be interpreted as the rate of change in the cost. So that the slope equals 10, we can interpret it as for each additional guest, the cost increases by $10. That's the slope interpreted as a rate of change.